everybody. For those of you who don't know me, my name's Brian. I just want to echo what Mayank said and say a big thank you for everybody for being here today. It's not often you get to be the first talker at a first conference ever, so it's a big privilege for me. I just want to say a big thank you to everybody for being here, especially on a Saturday. I do appreciate it, especially at 9 o'clock in the morning. So as the slide says, I'm going to talk today about architecting for change, or more specifically about adopting microservice architectures into your organizations effectively so you can derive the benefit that microservices are supposed to give to your company and try and avoid the pitfalls that microservices bring to your company. A lot of what I'm going to talk about today is based on things I've seen in the field over the last 6 years, mistakes I've made doing this kind of architectural style, and mistakes I've seen other people make trying to adopt this architectural style. If you want to tweet about it, that's the Twitter handle and the hashtag. Just make sure there's only one T in ExpertTalks. I made the mistake. I went to some really random website. So if you want to tweet about it, that's the handle. So before we get started, can I get a show of hands? Who here is involved in architectural decisions for their company or cutting day-to-day code? Let's get a show of hands. And who here is involved more in the business side? Yeah? Okay. So for the people that answered yes to the second question, I'll set your mind at ease. I'm not going to do a talk about architecture in the traditional sense. There's not going to be lots of architectural diagrams to bore you with for the next 40 minutes. And to the people that answered yes to the first question, what I am going to try and show you is the things that sit around the code within your organization. So we as developers, we tend to focus very much on the code. When we tend to forget that there's a huge amount of stuff that happens around us. There's a lot of complexity that we often don't take into account. And that's more what this talk is going to focus about. It's architecture according to that definition. So the design and configuration of a program or system. And what I mean by that is the structure of your teams, the structure of your operations, support teams, and your organization as a whole. So a little bit about myself, if this thing works. So, as I said, my name's Brian. I'm a technical partner with Equal Experts in London. I also work as the interim CTO for Equal Experts in Pune. I'm South African. That's the place I come from, and I don't want to talk about cricket in case anybody's been watching the cricket. I'm not very happy about that, I have to be honest. So yeah, that's where I come from. That's my town. And I've worked in software delivery now for probably about 18 years. I've been lucky enough in those 18 years to work across a huge range of different industries. I've worked from startups to huge multinational companies. I've worked for things like diamond grading all the way up to writing compressed video streaming software. And kind of the one thing I've learned over those 18 years is that IT companies or businesses in general tend to want three things out of software. They tend to always, I think you're going to relate to this, they tend to always want it done faster. And that seems to be picking up. Every time you get a project, it goes faster and faster. And they tend to want it done cheaper. So it's always cost and how fast we can do it. And then the third thing that they want is they want the ability to be able to change that software quickly and again, cheaply. And what that kind of leads us to in the industry is to try and develop new ways of actually architecting systems so that we can meet the needs of modern software. So the first thing is to try and understand where does that driver come from? Why do people want to be able to change software in the industry? So there's kind of the obvious ones that we kind of get every day. Most of our change comes through our product owners. We're quite used to sitting in a meeting and at the last minute, just before release, the product owner will run in and demand a new change. But that's kind of what I'm looking about. Change tends to come from places that live outside of our organization. So if you look at it, for example, if you cast your mind back to kind of 1995, before the birth of the internet, the world was a very different place. So the internet came about and it created a huge range of new marketplaces within the industry. And what that brought about was that we as IT industries needed to learn to adapt very quickly to that. So that's one source of change, new marketplaces. It creates a huge amount of change and it means we need to be able to very quickly move as an industry to capitalize on that change. Otherwise, we tend to either fall by the wayside and become insignificant. So that's kind of the obvious ones. New marketplaces are a very obvious source of change. But there's some other sources of change that are less obvious. So as I said, new marketplaces are a very obvious source of change. They create whole new businesses, and the people that are fast to react to that survive, and the people that are slow to react to that die. So if you think back, kind of 1995, if you wanted to buy a book, you went to a bookshop. If you wanted to buy a CD, you went to a CD store. We don't do that anymore. If you want to buy a book, you go to Amazon. And nowadays, you don't even buy a paper book. You download it onto your Kindle. So the companies that weren't able to adapt to that kind of died. I mean, I don't know what it's like in India, but in London, bookshops are on the way out. Nobody really goes to bookshops anymore. CD shops are on their way out. But a less obvious source of change in today's market is dying markets or commoditized markets. So at the moment, I work for a telco. And if you think back 10 years ago to when cell phones just became popular, when the iPhone was just coming out, people would go to companies because they either had exclusive rights on a phone. So the company I worked for got the exclusive rights for 3 years to the iPhone when it launched. So people would go to that company because they wanted the iPhone. Or people would go to a company because they had the best cell phone network. But cell phones today are completely different to what they used to be. It's become a commodity market. So I'm assuming it's the same here, but people tend to go to companies for cell phones especially simply because of the price. So what's happened to those companies is they've had to figure out ways to move very quickly into different markets. Otherwise, they force being able to drop all their prices and they lose the competitive edge. So in the UK, there's a company called 3. They offer a £15 kind of all-you-can-eat data package every month, and people are just slowly moving to them because they offer the same service. I can get exactly the same thing. So commoditized markets are another huge source of change. But the one part we, especially as developers, don't realize is we create a lot of change for ourselves. We think change always comes from the business, but we need to realize that, I mean, if you cast your mind back, how many relational databases were there 5 years ago? How many databases in general were there 5, 6, 7 years ago? There were probably about 5 or 6. You could count them all in one hand. Whereas if you look at the market today with the rise of NoSQL databases, if you do a Google search for databases, there's probably about 60. So we create a lot of change for ourselves, and a lot of that change is directed at being able to try to react to the changes coming in our market. But it's important for us to realize that we're our own source of change. Things like AWS have fundamentally changed the way we deliver software nowadays. The only way we can learn to adapt to this kind of change rapidly in our market is to build change into our systems from the word go. We have to embrace change as the only constant within the industry. And the cost of not doing that is huge. I mean, does anybody here still have IE6 in their companies where the only web browser you can use is IE6? No? It's a huge thing in the UK. You work in almost any bank, the only browser you can use in the bank is IE6. IE6 was end of life, I can't remember how many years ago. So the cost of stagnation is enormous in a company because what that essentially means is every system they have within that company that now relies on IE6, they're going to have to upgrade in one big bang. I think Microsoft is ending official support for legacy versions of IE in 2016 or something like that. So if you're as a company, if you're on that, that's huge operational risk, right? So stagnation kills. Make sure it doesn't happen. But it means that we as the industry need to develop new ways of embracing software architecture, the way we deliver software architecture, the way we actually structure our entire organization to allow us to actually be able to move quickly. So how have we been doing this up until now? So the quest to simplify system architecture has been going on for as long as I can remember, kind of since the 60s. And it originally started off with the client-server model, or 3-tier architectures. In 1995, the first job I ever got was for a huge retailer in South Africa, and we were building a custom SAP implementation for about 140 stores across 11 regions with one enterprise system at the top. And we built client-server applications that sat in every single one of those stores, and then we took the data and we used SQL replication to replicate it up and aggregate it at a regional level so they could report at a regional level. And then we did SQL aggregation again to replicate it up and consolidate it at an enterprise level. But still, I kind of look at the good old days. Systems were far simpler than they were now. We had kind of multi-year release cycles. It was kind of 2 to 5 years before we got a system out. It was much easier. As a developer, there was a lot less pressure on us than there is today to get things out in kind of 2 weeks. They tended to be mainly business-focused. We didn't really do client business-to-consumer software in those days. It was all for the internal use of the business or business-to-business software. But then the internet came along and it changed everything. The rise of personal computers came along and it fundamentally disrupted that market. So we needed to, along the lines of being able to do things faster and cheaper, we needed to find a way that we could start to build reusable components in our systems that we could then compose in ways we hadn't thought about beforehand. And that kind of gave rise to the rise of J2E and the likes. And what it basically promised is we would create all these. Who works with J2E? Does anybody work in J2E here? Yeah? Who still wants to work with J2E? 1, 2? Okay, there's a couple. So basically, Sun came along and they defined this huge J2E spec in collaboration with a lot of vendors, which is kind of why it's complicated. And the promise was that we could build reusable components, we could deploy them in these servers, we could compose them in different ways. But that promise, a lot of people didn't really feel that that delivers the promise because the specification around how to implement kind of entity beans is very complicated. I think to do a bean, you have to implement something like 4 different interfaces or something. It's a very complicated way to deliver software. You deploy them in very heavy, very expensive application servers that require teams of people to operate. It's hard to scale that horizontally because you have to have very big boxes to run it. You can't just spin up commodity software. So we as developers started to look elsewhere. And that kind of gave rise to the birth of SOA. So that gave rise to the birth of SOA and SOAP, which essentially SOAP was designed, initially it was called Simple Object Access Protocol. It's ironic, that acronym in like version 1.2 or something, because if you've ever done SOAP, it's not simple. The amount of WS kind of star standards on SOAP are mind-boggling. So as developers, we kind of looked at that and thought, yeah, that's pretty hard to do as well. It's designed to be protocol agnostic, so it doesn't work very well over everything, because when you make something truly abstract, it doesn't fit the purpose of anything very well. It tended to focus on, I mean, most of the SOAP I know you can use SOAP over like SMTP and JMS and stuff like that, but nobody really does it. SOAP tends to be done over HTTP. But the problem with it is it uses HTTP as a transport protocol and not as a platform. And I'll come to what I mean by that in the next slide. So we kind of took a look at SOAP and we're like, yeah, I'm pretty sure we can do better than that. And that kind of brought us on to where we are to today, which is essentially HTTP-based, REST-based microservice architectures. Who of you do microservices today? 2? Okay, couple. So for those of you who don't, quick definition, microservices, the simplest definition I've heard of them are that they're independently deployable, loosely coupled systems that can change. And that's kind of what we're striving for. They tend to be based on the premise that we as software developers don't know what we're doing, and the customer doesn't know what they want. So the only way we can actually build systems today is to do it in collaboration and to try and iteratively work through all these systems together until we come to a common understanding of what we're trying to build that meets what we're actually trying to get out into the market. They tend to apply mostly to REST-based APIs. They don't have to. You can apply them over different protocols. But most implementations of a microservice I've seen today tend to be REST-based using JSON. And when I said earlier before that SOAP tends to use HTTP as a transport protocol and not as a platform, what I'm referring to is by being a REST-based system, we get all the benefits of standardization for all the things that are out on the internet today. So we get HTTP caching out of the box, which can be a huge win if you apply it properly. I think there's a guy called Idi Dahan. He does a lot of talks on scalable software. And he says the cheapest request you'll ever make is the one you don't make. And what he means by that is if you're using HTTP caching appropriately, the client never actually has to make that call. It'll either be in the in-browser cache or it'll be in the kind of proxy cache sitting directly above them. So microservices can leverage all the power and infrastructure that sit in the internet as it is today. But it's important to understand the drivers behind why you want to adopt this architectural style in your company. The last slide I'm going to talk about is actually when you should know not to do it. Because there's a huge buzz around it at the moment. Unless you've been living kind of under a rock for the last 6 years, I've heard of microservices. It's the new Ruby. It's the new cool kid on the block. So you've got to be very careful that you understand why you want to adopt this style in your company. And as a developer, why should you care? Well, because it tends to deliver on some of the promises of the systems that have come before us. It actually is simple. In terms of application architecture, you have to understand HTTP. There's not a lot more to it to understand than that. You don't understand a whole lot of complex protocols. It's just HTTP. So it's very simple. They tend to scale very well if you build them correctly because you can put them on commodity software in the cloud. You can scale it horizontally. It's no big application servers to run. They tend to be cognitively simple, i.e. you can take the whole system, you can fit them in your head. It's easy to reason about. They do deliver on reuse because you can build a centralized auth component and you can deliver it across multiple places. And if you build them correctly, you can actually get them to deliver faster because they tend to be small package software. They start up quickly. You don't have to wait half an hour for your application server to boot. But like everything in software, they're a double-edged sword. So if you don't apply them correctly, you can get yourself into a world of trouble because they are distributed systems, and if you think building distributed systems is easy, try it. It's not. They're very complicated to build. The promise of microservices is reduced complexity for the application developer. I like to look at complexity in software systems like the first law of thermodynamics, which is essentially that energy can't be created or destroyed. And I look at complexity in these architectures the same way. It can't be created or destroyed. It just moves. It moves somewhere else. So it was in the code. It's now somewhere else. And in microservices, where does it move? It moves into the infrastructure. And DevOps is a direct response to the fact that the amount of applications we're increasing, the amount of applications we're deploying has increased quite substantially, and we need an automated way to deliver these systems reliably, consistently, repeatably. So if you're not doing automation of your infrastructure, this is not going to work for you. There's a huge amount of buzz from a lot of companies, so Netflix is kind of the golden child of microservice delivery. But unless you actually work for Netflix or you have a business that is like Netflix, you're not Netflix. So try and avoid falling into the traps of, well, the cool kids are doing it, so I'm going to bring it into my company, and I'm going to adopt every single style that they do. You've got to be careful of who you follow and who you listen to as well. Don't buy into the hype. If you've been looking at any of the forums about microservices, there's a huge amount of argument around what is a microservice, how big is it 100 lines of code, is it 5,000 lines of code? Is it 10 lines of code? And you can get bogged down into that a lot. So try and not listen to the hype. A microservice is what you need it to be within your company. And then the final kind of claim that you've got to be very careful of is that you can build it in any technology you want. I call that the CV-driven development. So what you'll get is people say, hey, but I can use any database I want. I can use any programming language I want. If you do that, you're going to get yourself into a world of trouble because you'll have 100 systems built in 100 different languages with 100 different databases. But that said, if you build them properly, they do deliver a lot of benefits, and they do help you to be able to scale your company. So how do we go about building these systems correctly? So I kind of broke it down into 3 areas, and these, as I said earlier, are based on I've seen in the field and kind of the takeaways I've had from that into how to do this more effectively. And they're broken down into 3 things. There's obviously the code. How do you structure your code and your applications? The second part is how do you go about designing for operations, because operations is incredibly important in this. And then thirdly, how do you go about structuring your organization? Because if you want to be able to change quickly, you have to change your entire company. It's no longer a software problem. Delivering systems to market quickly is an organizational problem. We all look at companies like Amazon and Netflix and we're like, wow, they're amazing. They build these great systems. It's because they don't have the separation between business and IT that most organizations have. We need to form a partnership between these 2 parts of the business. So everybody who has a stake in getting systems out is actually involved in the delivery of those systems. So it's those 3 things. So it's the code, operations, and infrastructure. And I'll go through, the first one we're going to talk about is how you actually go about separating your systems, which comes back to how big is a microservice. So how many people know what a bounded context is? Anybody? 1? No? Okay. So very loosely, a bounded context is, it's a model with a single responsibility that has concrete bounds. Right, that doesn't make a lot of sense. I kind of get that. So I'll give you an example. So if you look at, for example, take a cricket team. Within a cricket team, you've got the players and you've got the coaching staff. And the players have a responsibility of going out and they bat and they bowl, and they field and they can play wicketkeeper and they can change interchangeably. You can get bowlers who bat and batters who bowl, etc. And their responsibilities are to go out and win the game. Essentially, that's what they're there for. Then on the other side of that, you have the coaching staff. And the coaching staff are responsible for making sure that they know what the game strategy is, for picking the players, for making sure that the bus is there, that the hotels are booked, etc. So each of those 2 bounded contexts within that example have their own responsibilities. And the coaching staff aren't going to go and play in the team. So you're not going to get the coach going out to bat in a big game. They could, but they'd be overstepping their responsibilities, and they'd be crossing the boundaries. They're allowed to communicate with each other, and they communicate in microservice worlds over events. But as I said, they each have very clear boundaries, and they have very clear responsibilities within those boundaries. So if you're looking at your application, you can look at organizations within your company, and you can structure your systems around that. But that'll only get you so far, because what tends to happen is people will look with that, they'll think, great, I've identified a bounded context, I can now go about structuring my microservices. But what I would actually suggest is once you've gotten to that stage, stop and start to look at that bounded context you've identified in the terms of what are the different life cycles of modules within that bounded context. What are the SLAs of the modules within that requirement, within that bounded context? And if you start to look at that bounded context a bit more analytically, what you generally find is within that bounded context, you'll find that there's actually contexts within that that are also independent bounded contexts. So as an example of that, I've spent the last kind of 3 years of my life working for an e-commerce system that I inherited that had been kind of in development for about 2 years before I got there. And one of the systems within that is a product catalog. And the product catalog was delivered as a microservice with an API. It tended to have a consumer-facing API, and it had an administrative API where people and prices and stuff into the system. And they delivered that as one microservice which got deployed to production. But the problem with that is each of those modules within that actually had fundamentally different requirements. So the consumer-facing APIs had to be horizontally scalable. It had to be public-facing, so we're not that worried about security around it. It needed to adapt to the needs of its consumers. Whereas the admin API didn't need to be horizontally scalable. It needed to be secure because you don't want anyone on the internet to be able to change products within your company. It needed to have validation on its model. So as a result of that actually being deployed as one application, what it had done is it had complicated the entire deployment of that system, because now your operations team are going to have to go and write complicated firewall rules to make sure that nobody on the internet can actually hit your admin APIs, that people can't manipulate your software. The deployments of the systems got complicated because they essentially had different life cycles, so we were deploying software a lot more frequently than we needed to be because the admin API needed to change. So if you start to look at your systems in terms of what are the SLAs, how frequently do they change, it allows you to then realize within that product catalog example, we had 2 microservices. And if we had separated those microservices on that basis, we would actually have simplified our whole lives. So that's one way to look at them. The second thing is once you've actually managed to decouple the systems in that way or break out your bounded context, it's important to define very clear interfaces between those systems. And the reason that becomes important is because if I go back to the original definition of the microservice I spoke about, the first part is independently deployable. If you can't deploy your microservices independently, all you've actually built it is a distributed monolith, which actually gives you the worst of both worlds. So be very careful to avoid that. You need to be able to independently deploy these systems to actually get benefit, because each of them have their own life cycle. The consumers of your services will change on a different frequency to what your services change. And by not defining clear interfaces, what you essentially do is you force all of the coupled parts of that system to have to deploy in step, which is very complicated. And your operations team are going to hate you for that. So be very careful about that. And once you've actually managed to separate your applications out like this with clean interfaces, it actually allows you then to start to define parts of your system where... Has anybody heard of a concept called sacrificial architecture? Sacrificial architecture. It's essentially a concept of that certain parts of your application are not going to... You'll build systems today that in 2 years' time, 1 year time, 6 months' time will not actually be fit for purpose anymore. And if you actually structure your applications like this with very clear interfaces, what it allows you to do is when those parts of the system aren't requirements anymore, you can actually throw them away and rebuild them with very little cost to the rest of the system, because as long as your interfaces stay the same, you can literally just throw those parts away, rebuild them, as long as you actually don't violate your contracts, which is quite a powerful thing to be able to do. For example, if the scalability requirements of a component in your system become vastly more than when they were in the beginning, there's very little point in trying to just change that application to meet those new scalability requirements. It often requires a completely different system architecture, which means you just say, fine, throw that part away, rebuild it. Which brings me on to APIs. So if any of you work in API teams, anybody? Okay. Do you tend to have multiple consumers that consume those APIs? Yeah? So the typical approach I've seen to building APIs is a product owner will come along and they say, we need an API to be able to create orders, for example. And the development team run away and they create an API and they put it into the market, and you'll have about 5 consumers hitting that, and they'll all end up hating you. And the reason behind that is because most APIs that we deliver are not actually what the customer wants. So what I like to term is we need to move towards what I like to term consumer-focused APIs. And all that means, it's a fancy term for talk to your consumers. When you're building an API, get in a room with the people that are going to use your APIs. Have a conversation with them about what they want the response formats to be, what they want the request formats to be, and more importantly, what is your versioning strategy for your APIs? Do you guys do versioning, the people that said yes to APIs? No? Yes? Some? Maybe? Okay. Most APIs I've seen, people tend to not do it. And the reason people tend to not do it is because it's complicated. And we as developers are lazy, we don't like to do complicated things. So out of that has come things like consumer-driven contracts, which essentially states, if you're building an API, what you do is you go to your consumers and you say to them, you guys write a test, I'll run it as part of my build to make sure that I haven't broken my contract with you. Which is a great way to do it, it's fine, you can figure out very quickly if you've broken your contract with your customers. But focusing on that without versioning, what it means is you tend to end up with very bloated APIs, because you can only add fields to responses. You can't take things away, because taking things away breaks people. So versioning is something that's incredibly important, and you should be able to version your request formats, your response formats, and your API. If you follow any of the chats around API versioning, there tends to be 2 ways to do it, one of which is through accept headers, the other one which is a URL level versioning, and it's like a religious war in channels around REST services. And actually, if you look at it, I actually think you need both. So the trick is, you might not need to implement it straight away. I would strongly advise you do, but if you're not going to do it straight away, make sure you have a strategy for doing it. And when I say a strategy, I mean when you need to version, you need to be able to version immediately. Not going, oh, okay, right, we're going to have to go do some work for 3 months to get our APIs in the state to version. You need to be able to version immediately. As part of that conversation with your consumers, you need to understand within a version what constitutes a version change. So if I'm adding a field to my response, is that a breaking change? It's very important to define those contracts up front so that everybody has a shared understanding. And once you have that shared understanding, it's important that you document. It's got to be somewhere that people can read. It's quite funny, I always find if you use a programming library, like, for example, if you look at Google Maps, if you want to figure out how to use Google Maps, you don't phone Google up and get a programmer in Google and say to them, hey, I'm trying to use your map and I'm getting a bit stuck here, how do I do this? You go to the documentation page for Google. But when we build internal APIs, this tends to get overlooked. I've seen very few internal APIs that actually document their APIs. So when I was saying earlier that you should build consumer-focused APIs, I mean talk to your consumers. Once you have that understanding of what your consumers want, develop your software as if you have no idea who your consumers are. And the reason I say that is because it tends to force you into designing systems that can be changed and used by people outside of your control. So another example of people that don't version software is they'll say, but everybody that consumes my software is within my control. I can just go and talk to them and say, hey, we need to change our software. But if you tend to look at your software from the point of view of having consumers that you don't know, it takes that mindset out of your head and forces you to design your APIs in a way that they can scale independently from any of the consumers that are using it. And documentation is a big part of that, because if I want to know how to use a system now, I just don't read the documentation for it. And it'll tell me exactly what my versioning strategy is, what the request and response formats are for each version, what the parameters to that API mean. There's lots of tools around there, but the one thing I would stress strongly to do it is make sure that your documentation is in some way coupled to your code. So what I mean by that is if either have your documentation generated off your code or your code generated off your documentation. Because if you don't do that, you're going to get them out of sync, and there's nothing worse than wrong documentation. Then finally, when you're returning errors or request response, make sure you use appropriate HTTP codes. They're very well documented. Everybody understands them. If you want to know what a 404 is, go to Wikipedia and it'll tell you what it does. So make sure you use the semantically correct response codes and HTTP status codes. And if there's confusion within that, sometimes a 404 can be confusing. It's like, well, did the API not exist? Did I get the URL wrong? Or did the resource, the entity I'm trying to retrieve, did that not exist? You need to be very careful about not being too prescriptive about your standards, because there's nothing that makes developers feel less empowered than being dictated to what to use by a bunch of system architects sitting up somewhere. So it's very important when you're defining standards for your organization that you involve everybody within that organization that has a stake in it. And I also find it's very useful when you're defining standards to define the behavior of the systems you want them to exhibit. Don't be prescriptive and say, well, you have to use framework X, Y, and Z. You should go about saying, okay, right, well, you can use any framework that adheres to these principles. These are kind of 3 recommended alternatives. If you want to use something out of that, you need to come and we'll agree on it, and everybody will agree on it. But define a limited set that people have choice so they feel empowered, and involve them in the decision-making up front. You could look at using external standards as well. They don't only have to be internal standards. A great example of that's HTTP. Adhere to HTTP, everybody understands it. You can scale up your development teams very quickly because you can go out to the market and you can hire people that understand HTTP. Or if you standardize on languages like Java or, I don't know, any other popular language out there at the moment, it's very easy to find people that can actually come into your organization if you need to scale your development teams. That said as well, don't be scared to actually use the appropriate technology if it makes sense, because you can isolate that to small teams, and you might not need, if you separate them correctly, you might not need to scale that individual team, you could scale the teams around them. Things like standardized metrics and monitoring. If you're not doing internal monitoring, don't do this, it's going to break you. You need to understand failure points in your system. So standardize the metrics and monitoring around your system so that your operations team can very quickly plug that into monitoring dashboards, get a very good view of what your system's doing. Then log file formats, deployment directories, configuration directories, any kind of standard. Make sure all your applications adhere to that. One of my colleagues actually talks about platform as a club, which is essentially, we're a club, we give you benefits if you come into our club, but you have to adhere to certain rules if you want to come into our club. Coupling. So as well, cohesion and coupling, it's the same thing, gets drilled into your head from when you were studying. Coupling is how systems are joined together. Cohesion is the property of a system that it has a single responsibility. But what we don't realize is when we go to this style is that coupling lives in a lot of hidden places. So we're great, we get these small systems, they're supposed to be highly cohesive because they all have a single responsibility. But what we don't realize is now these systems, we get coupling in the infrastructure, we get coupling between systems. And it lives in funny places that you wouldn't expect it to be. So great examples of that are services coupled on a database. So if you have a microservice, the rule should be that the only person who can talk to that system's data is that service. If you want to get at that data, you talk to the API. If you start to couple systems at a database level, it's all the same problems you get with code coupling. It's very difficult to understand who uses each piece of data, who owns the format, who's responsible for the schema of that data. Which systems writes data into it, which systems read data into it. So by all costs, avoid coupling at a database level. It's a huge anti-pattern when you move to this. Each of these systems should have their own databases. I've seen systems coupled at domain layers. So we basically create a library around shared domain models, and we share that across a whole bunch of systems. And then system A needs to change it, that breaks system B in an incompatible way. Or system A adds validation rules that system B doesn't expect. And that can get you into a lot of trouble as well. I've actually seen systems, that product catalog example I gave you earlier, the validation logic for the upload had leaked into the consumer API. And what it actually did was the validation logic was actually enforcing that an image existed. If I was uploading a product and it referenced an image, it validated that that image existed. What had happened then is if somehow that data got deleted because people were coupling at a database layer and were deleting data outside of an API, the consumer-facing APIs, when they requested that product, were actually 404ing. Whereas actually, I think as a business, what you would want is you want the product data back with some kind of default image rather than a 404, which breaks your entire page. Less obvious are things like shared test stubs. We had a system where we delivered a test stub for part of our system. It had test data in it. That test data got distributed across 5 teams. Team A would change the data. It would break everybody else's build. So if you need to do something like that, make sure you separate the data from the actual delivery mechanism. So let each team plug their own data into the stub. And if at all possible, just use standard stubs like YMOC and stuff like that. The last part I just want to go through quickly is shared logic moving to your consumer APIs, into your consumers. And this is a direct consequence of not talking to your consumers when you define your contracts. So what happens if you don't talk to consumers when you define your contracts? As I said, everyone ends up hating you. And what they do is they stop talking to you. So when they need changes done, instead of getting everybody together and having a conversation about it, they're just going to build that logic into their own systems. And when you start to change the API response formats, you break all of your consumers. They have to go and change all their logic again. So avoid that at all costs. Just talk to your consumers. I know it's a crazy concept, talking to people, but microservices require a different approach to testing. That's a crazy picture, right? This title on that is actually some tests you're better off not doing yourself. It's a little worrying, actually. But if you're going to start to adopt this style, I would actually suggest that the traditional way we write code is we follow, Spring actually created this thing, is we create interfaces, single implementation interfaces, which is a huge anti-pattern in itself. It kind of breaks the whole point of what an interface is. And then we inject those interfaces into beans, and that allows us to mock them out when we're testing. If you're following a service-based approach, the easier way to do it is actually focus more on integration testing. And what I mean by that is actually test the real code as much as possible. These systems are small. What you actually want to strive for is the ability to change the entire implementation of your system or the module without changing the code. If the functionality hasn't changed, I should be able to refactor internally without changing any of my test code. And the reason behind that, the reason I say avoid mocking is because mocking tends to end up with specification in code. You tend to say exactly in your mocks what the internal calls to that system are. It kind of breaks the whole concept of what encapsulation is. I shouldn't care. You want to focus on data in, data out. So if I give you this input, do I get this output out? So move away from mocking and focus more on actually testing the code. And if you're building APIs, test the code from the point of view of your consumer. So we've defined all these contracts with our consumer. We've come up with our SLAs, what they should do. We need to make sure that we, as the producers of those APIs, actually validate that we are adhering to those contracts. Because if we don't, they can come and point a finger at us. If we've defined a contract and we stick to it and you break, it's kind of your fault. And if everybody agrees to that, that's fine, but we need to validate that we're actually adhering to that. And once you've actually, so what you want to strive for is the ability to test that each of these services, these microservices, you can test them and you can validate that according to the contracts I've defined with you and the contracts of the systems I consume, that I'm correct. You can then move towards focusing your acceptance tests on literally journeys across all of those individual systems. So what you want to check for is I've made sure that I do what I say I do. Now, has everybody got the same assumptions? Do we all work on the same basis? And that allows you to drastically reduce the time of your acceptance tests. I mean, I've seen systems with acceptance tests running up to like 4 or 5 hours. That's not acceptable. You can't change quickly if you've got a 4 or 5 hour acceptance test cycle, because what happens is it'll break at 4 hours and 55 minutes. And then some developer's going to have to go and figure out why it broke. That'll take about 4 hours. You can't run it on your own box because it takes 5 hours. So try and focus the testing on the responsibilities of each system. Okay, so that's the end of the code stuff. I want to get on to designing for operations now. That poster actually used to be on the wall in the operations team in the company I used to work for. And I'll never forget, I had a discussion with the operations manager, and I said to him, I find that very worrying. And he said, oh, it's just a joke. And I said, yeah, it's just a joke, but somebody put it there for a reason, right? People say things in jest that they actually mean. And that's a direct symptom of the fact that we as developers often write systems without any consideration to how we run that in production. We write and we throw it over the wall at the operations team. And the operations team, who then are incentivized or responsible for keeping systems up, becomes their problem. So don't do that. As I said, we need to move towards being far more collaborative as our teams. And this means that we need to start designing our systems with operations in mind. So what do I mean by that? I mean, if we're going to service-based architectures, it gets even worse because we've now got hundreds of systems to monitor. So make sure we design the systems for failure. So if I'm making an outbound call to an upstream service and that system starts to fail, I need a dashboard that shows me which system failed immediately, because you're going to be going through a huge number of transactions and there's nothing that slows you down or breaks your SLAs more than trying to figure out which of these systems slowed down. Because what will happen is the system at the very bottom will slow down. If you don't use things like circuit breakers, that system's slowdown will cause the system above it to slow down because you'll block all the request processing threads. The system above it will slow down and so forth, so on and so forth, until all the way back up to your kind of load balancers, you'll literally lock the entire system. So using systems like circuit breakers, which are essentially just a very simple way to wrap outbound calls to make sure that you can define a failure threshold and expected response times, and when the upstream system exceeds that response time, it automatically terminates the call and records that. And when it exceeds the threshold, the circuit breaker opens and it marks that system as down. It stops trying to call it anymore because it knows that system can't respond. And the benefit of that is actually allowing that system that's struggling to cope, it stops sending traffic to it. So that system can then slow down as well. So circuit breakers are a very good pattern. As I said, you can put it up on a dashboard. You can see immediately which system went down. The next thing is in-process system monitoring. So traditionally, the way we deploy applications up until now is web applications. We create a WAR file, we deploy it in Tomcat, and the worst anti-pattern is running multiple WAR files in the same Tomcat. Because when you get an out-of-memory error, which application caused the out-of-memory error? It's very hard to determine that. So building in-process monitoring into your systems allows you to figure out very quickly how your systems are behaving, moving away from deployment methodologies like Tomcat towards fat jars, which have their own embedded web container, are very desirable because they're very quick startup times. They're very easy to reason about. The configuration for that web server can be deployed very quickly with that actual fat jar. And there's a number of tools at the moment like Spring Boot, Drop Wizard, that are designed very much along this frame of mind. So they have built-in system monitoring, built-in in-process monitoring. They can tell you per request, per resource, the number of 200s, 300s, 400s, 500s you're getting, what the 1 minute, 5 minute, 15 minute rate of that is. And that just allows people to actually look at those dashboards and realize what the system's behaving like over a period of time. You start to understand what systems behave like during a natural point of the day. So like you can look at a board and go, hey, that's normal behavior for 1 o'clock. Or actually, no, the system's starting to, something's wrong here. We need to figure out what's going on because that's not normal behavior for 1 o'clock. And the reason I say standardize on that is because if you have many of these systems, these guys can create standardized dashboards and just plug systems into them. So focus on, that's kind of, as I say, designing with operations in mind. The final part is log file formats. So the biggest gripe I've ever had around log file formats as a developer is you'll always get the operations team coming to you say, can you just give me a list of all the errors you log in your system? And can you give me an error code for that and a description of what they mean? And that as a developer, because we tend to think of that as an afterthought, is a nightmare. Because it now means you have to go and look at every single log that you're logging out in your application and figure out what somebody should do about it, what error code you should assign to it. But there's very simple ways. If you actually think about this up front, you can actually, a very simple way to do it that I've heard was externalize all your log messages into, as if you know you're doing internationalized applications, externalize your log file formats into a message bundle. And then use the error code as the key into that message bundle. And what that means is at the end of the day, you have one file that tells you exactly all error messages you log out. And then all you need to do is give that file to someone and say, this code means this code means. So if you think about this stuff up front, it's actually not that hard. Then the operations team need to start focusing on automation. So you're going to be deploying this stuff a lot more frequently. Ideally, if possible, you want to move away. Sorry, that's not very clear, is it? Ideally, if possible, you want to move away from deploying to physical infrastructure because almost every organization that I've ever worked in, physical infrastructure takes forever to get procured. I worked at a company, it took me 7 months to get a server. And the ironic part is I actually never got the server. But after 7 months of going through procurement, I still actually didn't get the server. So if you're going to be building hundreds of applications that you need to deploy, you've got to deploy them somewhere. So if at all possible, move to the cloud. It's not always possible for every company. So if you can't move to the cloud, start to focus on things like containerization. So Docker and whatever the alternatives are. Because that allows you to take a piece of hardware that you have. Some of the systems I worked on had 28 cores, 96 gigs of RAM. They were running 4 applications on it. Those systems were so underutilized. So if you then threw Docker on top of that, you could deploy multiple applications. And it gives you the kind of container isolation that you need. And then once you've managed to move to that kind of architecture, you need to figure out how do you automate it. And automation applies to the obvious stuff like builds. How do we go? We build unit tests and we check them in, and then they run in CI. That's a form of automation as well. And by the way, if you're going to do that, make sure the build command you run on CI is the same one you run on your development box, because that helps you to isolate failure very quickly, because if you don't do that and you're running different commands, you get different results. But automation also, what I'm talking about refers to things bigger than that. So how do you get your Jenkins box set up in the first place? How do you configure your agents? Are they manual? If you're setting them up manually and you're installing a JDK and you're installing certain jars within that JDK or JRE, that's not repeatable. When your team leaves, somebody's going to come along, they're going to have no idea how to set that Jenkins box up again. So automation refers to that as well. Automate the installation of absolutely everything that you possibly can, because it makes your life a lot simpler as you go forward. It also refers to automation of deployments. So we want one-click deployments that are consistent across deployments to development, staging, performance, production, and you should be able to externalize the configuration for that automation. So if I now need 4 boxes in performance, I just go and type in 4, run my automation again, it spins up the boxes. The other thing that automation refers to, which is actually less obvious, is when your systems fail, how do you get the information out of them? So obviously when you're in a situation where your systems have gone down, the first thing you want to figure out is how do you get the system back up quickly? But you also need to be able to give the developers the information. They need to figure out why the system failed. So this talks about making sure you configure apps to, for example, in Java, do a heap dump on out of memory, so that I can just take that heap dump, go away and analyze it, and I can just reboot the system to get it up. Also, make sure you've got scripts in the box that you can get thread dumps quickly, or if all possible, build it into a standard way that you can just click a button and you can get thread dumps from every system, so you can understand why it failed. You can get the application up and running again very quickly. So the last part about how you can go about this is organizational change. So as I was saying earlier, traditionally companies work where you have the business on one side and you actually have the IT department on the other side, and the business tends to shout at the IT department and the IT department run around trying to deliver what the business wants. We can't carry on working like that. We can't change systems fast enough. We have to actually work as a partnership. So the change I'm referring to goes across your entire application, all the way up to financing. We tend to finance projects on a project-based model. So what that means is the business will say, okay, right, we're going to assign £1 million to develop application XYZ. It's going to take 6 months. We'll spin up a team, and after 6 months, when that project delivers, we spin the entire team down, and they will go away and do something else. Then 2 months later, when we need new changes to that system, we spin up an entire new team who have no understanding of the domain model because everybody who was working on that's gone. And the software just atrophies if you do that, because standardization only gets you so far. Domain knowledge is very important within an application. So if at all possible, and I know it's a very difficult thing to do, is to start sowing the seeds of moving to product-based funding models. So view these teams as products who build long-lived systems and make them responsible for those systems. So define what the objectives are for that team and make them responsible for the running and operation of that team as much as possible. It's not always possible to make teams responsible for running, because like in a bank, it's illegal to do that. But if you can, strive to get the teams who build the software to run them, and make sure you have everybody who you need to build that team, to build that product within the team. So that's product owners, DevOps, QA. Just one thing, DevOps is not a buzzword. We tend to focus nowadays, it's another buzzword that comes in the market. DevOps is not a role, it's a mindset within your team. Everybody in your team should understand what it takes to get your system through every environment all the way to production. And if you don't have that, you've essentially got a bottleneck within your team. When that DevOps guy leaves, you get exactly the same problem. So just make sure you adopt that kind of mindset, and then make sure you've got QAs, UX, researchers, every single person you need to get a product to market within the team. And as I say, form them as a product and incentivize them as a product. Lastly, how you get software into production. Most softwares that I've seen, most software release processes are very heavyweight. They involve like change control calls, and you're going to fill in 7 documents in triplicate. And that's an attempt to reduce risk. But the problem is, we've moved so far away from those delivery models where we're delivering every 6 months that actually all these systems introduce is risk. Because it means a very small change that you deploy into production that causes a bug. You can't actually react to that bug very quickly. I mean, most of the bugs I see in production, we can actually fix and redeploy in 5 minutes. We can write a test, fix it, prove the bug, actually redeploy it. But because we have to go through kind of 3 different environments, we have to go on a change control call, and we have to do performance testing and all these things, it essentially means that we can't react to change quickly. So try as much as possible, break down those release procedures, and the only way you can do that is to actually build trust. So pick a system, Try and convince people to work like that. Pick a system that's not necessarily business critical, and start to build trust within your organization that actually automation is safer. That if I can automate my builds, I can roll them back quickly, I can roll them forward very quickly. And trying to change the culture within your organization to adopt a more integrated, collaborative environment. So lastly, how do you know when not to do this? So as I said, you've got to be very careful about why you adopt a microservice-based architecture, because it's not fit for every problem, and it's not fit for every organization. So the first way is, as I said earlier, don't do it because everybody else is doing it. Do it because you need to, because you have a requirement in your organization to do that. It's still okay to just build monoliths sometimes, or just build a web application. It doesn't always have to be distributed. If you're building an internal HR application, for example, it doesn't necessarily require the investment of getting a huge amount of infrastructure automation around it. I mean, I think deployment automation is always a good thing, but you might not need everything else that goes around it, because it's complicated. So if you're still doing waterfall, it's never going to work. So if you're doing waterfall, just look the other way. You're going to need a huge document, so don't worry about it. If you don't understand your business domain, so this one's quite a point of contention, because if you don't understand your business domain, you're probably going to build a wrong monolith anyway. So if you can't do automation infrastructure, and if you write poor monolith, you're going to write poor microservices as well. So if you're doing things like that, avoid this architectural style. Go and look at how you can restructure your organization moving forward, and then look at adopting this on a small scale later and building trust. And that's it. Thank you very much. Question. How much time do we have for questions? Sorry. Hi.
Hi. So one of the things that I was looking for was, like, if we are supposed to adopt for this change, this is good for greenfield product development. Let's say we want to develop a new product, but some of the products that are already being developed, there is a level of change that needs to be brought in. Some of the bounded context, right? They could be built in some older models, and then there are newer products that are being bought constantly by the companies, and they become an integral part of the product.
Okay.
So if you have to drive a change, is there any learning from your side that you have seen how to orchestrate this change across? Which are the modules to be picked up first, which are the ones to be picked up later on, and things like that, because that change is quite different. It's not like you go and build a new product altogether.
So you're talking about how you integrate with existing products within your company?
Yes.
So there's some of the patterns that we've adopted around them are building services on top of those. So for example, we work with a lot of SOAP-based services within our organization, very difficult to interact with. So what we will do is we'll build a microservice that sits on top of that and slowly start to strangle the functionality out of the SOAP-based system until we can replace it in its entirety. So does that answer the question? It's kind of wrap it and then remove it, if at all possible, is the easiest way to do that.
Right, but then what about the newer products that constantly keep getting on board, because now you've the company bought a new product, right? And that's supposed to be tied in as well. Now, are you saying that we also build microservices on top of the newer product that have been bought and then strangulate that?
Well, I think the problem is if you're buying products, this architectural style doesn't work in the first place, right? Because you're going to be kept to the timescales of the vendors. So if you want to isolate yourself from changes in those products, then yes, I would suggest you build an API on top of that. What I've seen in a lot of organizations is they actually buy a product and then they modify the product, because most products are designed to kind of be across every consumer. They don't fit the needs of a specific company. So what people do is they buy a product and they modify it and they lose their upgrade path. So what I've seen more people adopting nowadays is they actually buy a product, leave it as a commodity, and put the modifications in a service that sits above it, so that you can actually swap out the product underneath it. Obviously, it's never that simple, right? Yeah. It's kind of, that's the end goal. It's never that simple. But as much as possible, yeah, put a service above it and put your modifications to that product. Actually, I've seen a lot of companies moving towards that style, but then customizing products themselves.
Can I ask one more?
Sure.
Have you written microservices which go across the bounded context for transactions?
You mean actually ACID transactions? ACID transactions don't work in HTTP. I'd suggest if you're doing that, you should look at doing something alternatively.
Okay.
Just by its very nature, you can't do transactions across HTTP. I know Red Hat are actually trying, which is very worrying. So yeah, I would suggest trying to avoid that if at all possible.
Yeah, hi. My name is Vijay Apsangi, and I belong to a company called ID4 Realms. The question is regarding couple of years back, we have a product-based company, and couple of years back, we tried to embrace a concept called OSGI, which is something similar to the microservices. Now then, by the time like we were into it, like couple of months, we realized that OSGI is not taking that much traction in the market for some reason. And then we also realized that since our product was like modularized, there were a lot of interdependencies between them. So the question is that why did like kind of OSGI failed and microservices is taking over? And second part is why that if there are a lot of interdependencies between modules, then is microservices suggested way?
I don't have experience with OSGI, so I can't really tell you, but I would suspect it's a specification that came out of Sun or Oracle, so it's probably way more complicated than it needs to be. And you've got the reason I think microservices are gaining a lot of traction is, again, because the only thing you really need to understand is how to split the application up. There's, in terms of dependencies, as I said, if you look at things like versioning your API, you get that dependency comes built in. As long as you approach it properly, obviously it's not built in. You have to, but if you thought about it, it's fairly simple, right? They're just standard applications. I think OSGI is it's the module where it picks it up and runs and everything. I'm not really sure. I know Sun, if I'm not mistaken, in Java 9 is coming out. I've not seen any. I think people tend to go down this model because it's basically just an application. You just build a standalone application, and then you think about how to get it into production. So I'm not sure that really answers your question. I don't have a lot of experience with OSGI. So. Yeah.
We understand the importance of API versioning, how important it is to specify or select the response types. In the REST, we always try to have the JSONs, or we can have all. So how it is important in terms of architecture to select the response types?
So you're saying should your service provide JSON, XML, CSV? Yes. I think that it's in the name, right? REST is representational state transfer, which means a representation. I should again, use HTTP as a platform, except headers are built into the platform. So as a consumer, you should be able to ask for XML. You should be able to ask for anything that you actually want to do. So I think it's important, yeah. You need to, it kind of goes into response level formatting, where we use accept headers to specify vendor-specific media types. It's built into the platform. Utilize the fund. I think the problem is we tend to build too many REST APIs that are based on JSON. Yes. And we think JSON is the be-all and end-all. Not everybody consumes JSON. Not everybody wants to consume JSON. So I'd say it's quite important to be able to support multiple. It kind of also depends within your organization who you're building for. Because if you're building within your organization and going back to standards, you've defined that our standard response formats are JSON, then I wouldn't worry too much. If I'm building for consumers outside of my control, yeah, you should probably think about that.
This was regarding the versioning. We know versioning is very important. So I have 3 questions for that. Like one is, when we have this microservices, the idea is to deploy them very quickly, like change and deploy them. So how should I decide like how many versions should I keep for my microservices?
It depends on your discussion with your consumers. So you should be having a discussion with the consumer saying, we would ideally like to only retain 2 versions, the current and the one before that, and any versions before that will deprecate after 3 months or something. It should be part of the discussions around your versioning to agree that between your consumers to say, because for example, if you're building APIs for tool-based systems, like in-store POS systems, they tend to have very infrequent release cycles. So actually deprecating an API after 3 months might not be good enough for them. They need it to last a year. It's context dependent.
Now there is a case where if you are developing a SaaS-based multi-tenant product where you will have multiple customers. So in that case, we have an APIs, and now the chances are that we have a consumer-specific APIs also. Mm-hmm. So now there is a consumer-specific API, and then there is a versioning of API. So the things start a little bit complicated when the scenarios.
That's an interesting point, because I would say if you've got SaaS-based systems, you probably shouldn't be building consumer-specific APIs. Kind of goes against the whole principle of it, right? It should be a soft... I think the problem is most consumers of APIs I've tended to work with want the API to do everything for them. And it's actually a trade-off between what the API does. The API, as much as possible, should be standard for all consumers. And the consumer should have to do some work themselves. They need to be able to take the API and transform it to whatever performance they want. If you do want to do consumer-specific APIs, again, I think you could start to look at, depends whether it's an API itself or whether it's actually just the response formats. If it's the API itself, I don't know, do you guys fork the code base and have a separate deployable, which sits under a separate URL that consumer hits? Or if it's just response formats, you can use accept headers. It's a tricky one to do that. I would, as much as possible in our teams, we try and avoid building consumer-specific APIs. We build generic APIs, and we tell the consumers they have to do some level of transformation. So, for example, we build location-based systems. The consumers actually do the location-based search. Figure out which one's closest to them. Because in terms of scalability, we specific API responsibility to the client.
And the last one is, I see there are several approaches when it comes to versioning, because you can specify the version as a URL, you can specify the version in the custom headers or the normal headers. And there are different companies, like big companies, who are using different strategies.
Mm-hmm.
So, do you have any experience or guideline or recommendation?
Yeah, so we use, sorry, I know you want to. We use vendor-specific media types to version response and request level formats. So if we have API version 1, we might have multiple versions of the response format within API version 1. And I don't want to version my URL every time my response format changes. So we use vendor-specific media types and accept headers or producers headers to do that, or consumes headers, sorry. And we use API level versioning if the actual API has changed. So if we fundamentally change the parameters you pass to the API, via of the API, we then version at a URL level. And versioning at a URL level is nothing different than, you can actually clone that code base and deploy it completely separately with a totally different URL. The version in the URL is just for you and I to understand it's a different version. But I see them as having fundamentally different purposes. One is to let the consumer pick what format they want, because there might be versions behind you, and the URL level version says, hey, this API is fundamentally different. We don't accept the same parameters anymore, or we don't exhibit the same behavior anymore. Does that answer your question?
So you mean it should be a mixed mode?
You should mix them, yeah. You should use them, but it's not one or the other, it's both.
Okay.
Yeah. That's my take on it.